Hello, my Calculus 3 family. Today we're going to talk about limits of vector-valued functions, but I'm kind of going to skirt the rules a little bit to just do limits the way I want to do them, because I don't really want to get into this whole delta epsilon definition of a limit. If you want to know about that, I will probably give you some resources to figure that out on your own, but I got to be honest, we're just going to do limits my way. So full disclosure, this is not the official way to do limits. We're just going to call it Mrs. Vibber's way and let that be that. And let's be honest, I'm pretty awesome, so it's going to be good. It's kidding. I can't even say that without laughing. So let's keep going. All right, so if I want to evaluate a limit of a multivariable function, normally we have the limit as like x approaches 0 or something. Well, if I have a function that's got x's and y's in it, or an expression, I should say, that has x's and y's in it, I need to let both x and y approach values. So if I want to evaluate the limit as xy approaches 1, 2, one way to do that is to just plug in 1 and 2. But before you do that, you want to consider this expression and see if it's going to have a problem with DNE or something like that. And on a quick glance, a 1 and a 2, not going to cause me any problems. So I'm just going to put 1 in for x, put 2 in for y, and then realize this is going to be 10 over 5, which is 2. Cool. Fine. Show that this limit equals 0. Okay, so I'm just going to look at 0. Whoa, farts. Well, that's different. This time, if I go to plug in 0, I'm going to have 0 on top and 0 on the bottom. And you learned last year that 0 over 0 is undefined. But if you have a limit that goes to 0 over 0, that means it could be just about anything. So, God, I got to show that that limit equals 0. Well, what did we do last year? Last year when I had 0 over 0, we did that L'Hopital thing, remember? And L'Hopital was where you took the derivative of the top and the derivative of the bottom, but my top and bottom have y's. So here's what we're going to do. The other thing we did last year is when we had something that we didn't know what to do with, we approached it from like a different direction, okay? So if I came back up here, I could have rewritten this as the limit as xy approaches 1, 2. But what if I came at 1, 2 like from the left, from like x equals 0.9, 0.999, 0.9999? So if I approach x coming at 1 from the left, and I approach y coming at 2 from like above, remember those sided limits? Well, what we're going to do this year is we're going to think of those sided limits from everywhere. So if I want to come at the point 1, 2, I could come at it this way. I could come at it that way. I could come at it this way. I could come at it this way. There aren't just two sides anymore. There's an infinite number of sides. So if I want to show that this limit equals 0 and I can't just straight up evaluate it, what we're going to do is we are going to approach 0, 0 using functions that pass through 0, 0. For example, how about I approach this along the line x equals 0. X equals 0. Yeah, x equals 0 is a path that goes through 0, 0. Yeah, of course it is. So what we're going to do is we're going to say x is 0. End of story. No ifs, ands, or buts. X equals 0. So now, if x equals 0, I'm really just taking the limit as y approaches 0, because x is already there, of 5 times 0 times y over 0 plus y squared. Well, 5 times 0 is 0. 0 divided by y squared is, y squared, and I'm taking the limit as y approaches 0. Well, 0 divided by y squared is 0. And then you may be thinking, wait, Mrs. Weber, hold on. Isn't that still 0 over 0? No, because this 0 on the top is a real 0. I am approaching along the path where y equals 0. Y isn't approaching 0. Pardon me, x equals 0. I am approaching along the path where x equals 0. Y is approaching 0, but x is already there. That 0 on the top is an actual real 0. Okay, so I have 0 divided by y squared, where y squared is some other number besides 0, but really close, but it's not 0. 0 divided by a number is 0. I can do the exact same thing along the line y equals 0. So now if y is actually 0, x is approaching 0. So I have 5x squared times 0 over x squared plus 0, which is really 0 over x squared. And that's 0 again, because again, this time y is 0, x is getting there, and 0 divided by something is 0. Okay, well, does that show that the limit equals 0? No, unfortunately, it does not. I would need to approach from every single path. And here's where we're going to go with the Mrs. Vibber way. If I ever tell you that I want you to show that a limit equals something, I want you to use 3 paths and show me that all 3 paths go to the same place. Okay, that is not a proof, but I am telling you ahead of time, I know the limit equals 0. Make sure you can show me through 3 paths that you get 0 each time. So now let's go with something funky. Along the line x equals 0, along the line y equals 0. What's another line that goes through 0, 0? How about y equals x? So now let's go along the line y equals x, because that passes through the origin. So if y equals x, I'm going to replace all the y's with x's. So now I'm going to say x is still approaching 0, but all the y's are going to turn into x's. Okay, so now I have the limit as x approaches 0 of 5x cubed divided by 2x squared, which is the limit as x approaches 0 of 5 halves x, which is also 0. Okay? So if you know what a limit is going to equal, what you want to do is approach it along a couple different paths and show me that you all get that same value for all your different paths. Now, if you want to show that limits do not exist, you need to test as many paths as possible, or I shouldn't say as necessary, until you get 2 unequal limits or 1 limit where the answer that is with an answer that is does not exist. Okay, so let me show you what I mean. Number 3 here. I've got the limit as xy approaches 0, 0 of x squared minus y squared over x squared plus y squared, all squared. And if I plug 0, 0 into that, I get 0 over 0 in the beginning. All right, so I know I can't just straight up evaluate it. So now we're going to try paths. Easiest paths to try that you should always start with, oops, I didn't mean to write limit, is you want to always start with the path of x equals a number or y equals a number, because they're just the easiest way to go. So if I pass along this using the line x equals 0, then all the x's are going to become zeros, and y is the only thing I got left. So I have 0 minus y squared over 0 plus y squared, and that's squared, which is the limit as y approaches 0 of, well, that'd end up being negative 1 squared, which is 1. Okay, so along the path where x equals 0, I get 1. That doesn't mean the limit's 1, because I told you these limits that we're about to do are all limits that don't exist. And I will tell you that ahead of time, all right? I will tell you, show that this limit doesn't exist or show that this limit equals 4. All right, now let's go along y equals 0, which means it's the limit as x approaches 0 of x squared minus 0 over x squared plus 0 squared. And that's going to be the limit as x approaches 0 of 1 squared, which is, oh, still 1. Well, I mean, okay, I told you the limit didn't exist, right? So getting 2 of the same means that 2 of the paths go to 1, but there's more paths. Let's try some more paths. So let's go along y equals x, all right? That's another thing that passes through the origin, and it's relatively easy to deal with. So the limit as x approaches 0 of x squared minus x squared over x squared plus x squared squared is the limit as x approaches 0 of 0 over 2x squared squared. Oh, okay, that one's 0. So now I have a limit that goes to 0 and a limit that goes to 1. So overall, the original limit does not exist. Okay. All right, that's what we've got. So I'm going to see what my timing is like right now because I don't want this video to get too long. I'm at 10 minutes. Cool. I'm just going to finish the last example on here, and then we'll do the rest together or in another video. All right. So example 4 here, 0, 0, same thing. Okay, so let's take the limit as x approaches 0, and we'll go along y is 0. So we're following the path y equals 0, which makes this x minus 2 times 0 over x squared plus 0, which is the limit as x approaches 0 of x over x squared, which is the limit as x approaches 0 of 1 over x. Oh, and as x approaches 0 from 1 over x, if I approach 0 from the left, I'm going to have negative infinity. If I approach 0 from the right, I'm going to have positive infinity. Hey, look at that. That limit doesn't exist. Don't need to do anymore because I already figured out that the limit didn't exist. I don't need to do 3 paths this time, just 1. That's all I needed. All right. That is limits of multivariable functions. Now, on the back, I have a bunch more here, but I don't want this video to get prohibitively long. So I am going to stop there, and then you will either watch a follow-up video or see me in class to go over the rest of these. I hope everybody is having an excellent day. And then I will leave you with a stupid joke today. My stupid joke for the day is this. What do you call an elephant that's wearing slippers, a tutu, a Spider-Man mask, and earmuffs? Doesn't matter what you call him. He can't hear you anyway because he's wearing earmuffs. I know, it's a really terrible joke. I'm sorry, but that's what I'm here for. Have a good one, everyone.